question 7, let's do this. We have some apparatus. We've got a bag of marbles, we've got a weighing balance, and we've got a measuring cylinder with water in it. Okay, what we have to do is measure the density of glass. The marbles are made of glass. How could we, as accurately as possible, find the density of the glass? So we need to find density of glass that's been used to make these marbles. So first of all, we've got to think density is equal to mass divided by volume. So we've got to find these two things. Let's do the first part because that's easy. Measure mass of marbles using the weighing balance. There we go. There is mark 1 of 4. Right. Volume a little bit more tricky. So hopefully what you remember is that if we put a solid into a liquid, we are going to displace a certain amount of that liquid. And the amount that we displace is going to be equal to the volume of the thing that we're measuring, the solid that we're measuring. So that's how we're going to calculate the volume of these marbles. Now there's two ways to do it. We could measure where the water level is, put the marbles in, and then measure where the water level has risen to. So for example, we would now have a measuring cylinder. We're going to assume it's quite a big measuring cylinder. We haven't been told otherwise, so we can imagine what we like. And now the water level's up here because we have a load of marbles in the bottom, and that's pushed the water level up. So we can measure the difference, measure the change in water level after adding marbles. Okay, and that will give volume. This is volume. So there's mark 2. Now, there are other ways you will have done it in class. You might have the measuring cylinder with the water right at the top, and what you would do is perhaps collect any water that overflows when you put a solid in, or you might have used a displacement can to do that. But we're going to go with that method for now. So what do? We've now got the mass and the volume. We are then going to divide, if I can actually spell, divide mass by volume to get density. And that is going to get us a mark. Right. We are told that we have to do this as accurately as possible. And so there needs to be somewhere in your answer that that gives that mark for accuracy. Now there's a couple of ways to do it. It could be about making sure that the water level is measured accurately with the marbles. It could be about measuring the mass of the marbles. Maybe you say you put the, you measure the bag of marbles, and then you remove the marbles and measure the mass of the bag and take that away. It might be something as simple as measuring the water level at eye level. So measure the water level at eye level. I'm repeating myself there, that's not the best English, but that is going to get you the marks. Okay, so some reference to how you would be as accurate as possible. You might use several marbles, so don't just use one marble. That would be another way to get that 4th mark. If you only use one marble, then you're more likely to get a bigger percentage error in your final result. So you could measure the mass of 5 marbles and the volume of 5 marbles and use that to do your calculation. So a number of ways to do that. Right, I'm going to move on. B. We are going to need to do a calculation here. So we've got a beaker of water. We have 0.25 kilograms of water, and we're going to heat it up from room temperature up to 100 degrees, so up to boiling point. So as always, let's write down the equation. So the change in thermal energy, I'm just going to use the symbols, the change in thermal energy is equal to mass times the specific heat capacity times the change in temperature. So using the symbols there, if you need to pause and have a look at your equation list, then do so. But that is the change in thermal energy equals mass times specific heat capacity times change in temperature. So then I'm going to write these down the side as I always do. I'm going to write in what we've got and what we need to know. So the beaker contains 0.25 kilograms of water. We are going to, we've got a specific heat capacity, of 4,200 joules per kilogram per kilogram Celsius. The total amount of energy is 84,000 joules. And what we need to work out is the temperature before it was heated. Okay, so we're going to work out the change in temperature. That's not going to be the final answer. We need to work out the change in temperature, and then we can use that to work out the answer, because what we're trying to work out is the temperature of the room, basically what was the temperature before it was heated. So we need to rearrange and make this the subject. So again, I'm just going to do that now. Change in temperature is equal to the change in energy divided by the mass times the specific heat capacity. So let's put all that in. Remember, now we can just take our values from above. 84,000 divided by 0.25 times 4,200, and that's going to give us the temperature change. So let's plug all that in. 84,000 divided by 0.25 times 4,200, and that's going to give us 80. So that's the change in temperature. We were told, if you remember, that we're boiling the water. Okay, so the water was heated to 100 degrees. If the temperature changed by 80, then that tells us that our final answer is, what was the temperature of the water before? Well, it was room temperature, we were told, but specifically it is 20 degrees. Okay. Next, 4B2. The heating is going to continue, so they're going to carry on heating that up, and the water is going to turn to steam, and we're told that 0.15 kilograms of the water turns into steam. The thermal energy needed to do that, so the change in thermal energy is equal to 0.34 mJ. We'll talk about what that means in a second. So we need to work out the specific latent heat of vaporization of water. So essentially, how much energy do you need to put in to turn a kilogram of water into steam? So our equation, again from the list, whatever year you're doing it, it's going to be the energy required to do that is the mass times the specific latent heat of vaporization. All right, so again, let's write down what we've got and what we need. Q is 0.34 mJ, and again we'll talk about that in a second. Mass is 0.15 was turned into steam, and we're trying to work out L. Okay, so let's rearrange the equation to make L the subject. So L is going to equal Q over M. Now here's where the important part comes in, because hopefully what you remember is that a capital M is mega, which means million. So that's going to be 0.34 times 10 to the 6. Oh, what am I doing there? Times 10 to the 6 divided by 0.15. Let's plug that into the calculator. 0.34 times 10 to the 6 divided by 0.15. And that gives us a value of I'm going to stick with two significant figures, 2.3 times 10 to the 1, 2, 3, 4, 5, 6. Sort my calculator out there. 2.3 times 10 to the 6. Now we've got to be careful. I haven't noticed that. We are given the value that we need to give the answer in. So I was about to say it's 2.3 times 10 to the 6 joules per kilogram. But actually what we need to leave our answer in is megajoules per kilogram. So we could have got away with not faffing around with this megajoules, but anyway, we did it as going with the units. What we need to do here is we need to transfer back to megajoules now. So I can divide that by 1,000,000. Let's do it 1 times 10 to the 6, and I won't make a mistake. And that's going to send us back to 2.3 megajoules per kilogram. So that's a 2-mark question. So actually, if you'd not seen the megajoules in that case, you'd have got away with it. Right, final question for this part. I'm going to go a little bit over, but it's been some bit more complicated questions. So volume of fixed mass of water. So your volume of water up here, I haven't filled in the whole scale. The important thing is what's happening here. And then we've got the temperature of the water. Now, what we have to be really careful here is that we are asked to describe the change in density of the water over the temperature shown. Now, what we're actually seeing on the graph is the change in volume. Okay, so the danger is we go, oh yeah, I can see what happens there. It reduces to 4 degrees and then increases to 11. But we need to talk about the density. So let's have a think. Density equals mass divided by volume. So if the volume is going down, the volume goes down, then the density must be going up. Okay, so they're trying to make sure that we really understand what we're being asked here. So the density is actually going to increase. So the density increases to 4 degrees C. Density, I should have put, sorry, this is 2 marks. I'm going to put 3 points here. There's only 2 marks though, so you need 2 of these points. Density is maximum at 4 degrees C. Density then decreases, so it starts decreasing even though this graph's going up. Remember, that's volume, so density decreases above 4 degrees C. There we go. Okay, that's question 7 done, and my son is pestering me now, so I'm going to go, and I will see you in the future for the next one. Thank you.